Okay, got another problem up here on the board. 3 sine 2x is equal to 1. In a minute, I'm going to ask you to pause the video and try to work that out on your own. What I'm asking for is these two things. I want you to find all solutions, so all values of x, and then I want you to find all values of x between 0 and 2 pi. Okay. What I've written up here, however, is how I suggest you do that. So start by finding the values of 2x between 0 and 2 pi, then find all values of 2x. Then you're just going to cut those in half to get these. You're going to have an n involved, and you'll just plug in values of n until you have all of the solutions that for x that are in that interval. Okay, so go ahead and pause the video. Welcome back. So I'm going to isolate my trig function. So I'm going to divide by 3. So I get sine of 2x is equal to 1/3. Now 1/3 I'm not going to get in a 30, 60, 90 triangle or a 45, 45, 90. So I know that here I'm going to be describing things in inverse trig. Still the same process. I'm going to have a solution in quadrant 1 because 1/3 is positive. So I'm going to have a value of 2x that's there. Sine is also positive in quadrant 2. So I'm going to have a 2x here with a reference angle. And this reference angle will be the same acute angle that I get as my solution for 2x here. Okay. There won't be any solutions in quadrants 3 or 4 because sine would be negative there. Okay. So here, if sine of 2x is 1/3 and 2x is an acute angle, 2x is just arcsine of 1/3. Okay. And here, my alpha would be this reference angle, arcsine of 1/3. So here, 2x is equal to pi minus arcsine of 1/3. So those are my two answers. So I'll have arcsine of 1/3 and pi minus arcsine of 1/3. Okay. Now, one quick note on this. I realized in the book, when they have things that are defined in terms of inverse trig, they almost always do that in the section where they ask you to give a decimal approximation. So they're asking you to use your calculator to get a decimal approximation for something like this. Remember, calculators are a little bit different, but for most of them, that means you're going to be hitting the shift key or the second key, and then the trig function, and that gives you the inverse trig value. But make sure that you know how to do that because you might need to do that on upcoming exams. However, I tend to, if you're just solving an equation, I tend to put that on the non-calculator part of the exam, meaning that I want the exact solutions. So I would want things expressed in terms of the inverse trig function. I would not want the decimal approximation. Okay. So as you're doing homework, if you get something like this, practice writing it this way, but if the answers in the back of the book are decimal approximations, then you're practicing using your calculator. And there are other sorts of problems that we're going to see in Chapter 7 where you will need to know how to use those inverse features on your calculator. So do make sure that you know how that works. Okay, excellent. So these are my two solutions. So now I can write down what all of my values of 2x could be. So 2x could be arcsine of 1/3 plus 2 pi n, or 2x could be pi minus arcsine of 1/3 plus 2 pi n, where n is an integer. And I find by writing it as an equation, I'm setting myself up so that I'll be able to solve for x, because if I know what 2x is, I'm just going to divide by 2. I'm dividing each piece by 2. So here, x is arcsine of 1/3 divided by 2 plus pi n. Okay. Arcsine is the angle. That's what I'm dividing by 2. 1/3 is the sine of the angle. I am not changing that. So this does not become a 1/6. I don't divide that by 2. I divide this whole thing by 2. Remember, this means an angle whose sine is 1/3. This means half of that angle, which is very different from an angle whose sine is 1/6. So do be careful that you divide the entire thing by 2. And then I get plus pi n. Okay. And here, if I divide through by 2, I'm going to divide each one of these 3 terms by 2. So here I'm getting pi over 2 minus arc sine of 1/3 over 2 plus pi n. And of course, for both of these scenarios, n is an integer. Okay, excellent. So now, that gives me all my values of x right there. So now I want to get the x values that are in 2 pi. And I've pretty much started to see that I can expect to be plugging in values for n to get my solutions. And I'm expecting to get twice as many solutions as I had here. So I can expect to plug in 0, which will give me basically these solutions without adding anything, and 1. Okay. So if I'm going to go ahead and write that out in a table, but you may find that it's not necessary to create the table, and it's totally fine if you don't. I'm just going to call this A and this B. So working with A, I'm going to try n being 0 and 1. If n is 0, I'm getting arc sine of 1/3 over 2. If n is 1, I'm getting arc sine of 1/3 over 2 plus pi. Okay. Now, I know that's between 0 and 2 pi. Arc sine of 1/3, remember that was an acute angle. So half of it, that's still an acute angle that I'm adding to pi. That's just going to put me somewhere in quadrant 3. But I can see if I let n be 2, I get plus 2 pi, I'd be bigger than 2 pi. So those are the 2 solutions that I get from this first possibility. And then if I look at B with n equaling 0 and 1, if n is 0, I'm just getting this. So we'll have pi over 2 minus arc sine of 1/3 over 2. If n is 1, I'm going to add pi to that. Now, if I add pi to that, I can actually combine that with the pi over 2. So I'm going to just have pi over 2 plus pi minus arc sine of 1/3 over 2. Of course, this is pi over 2 plus 2 pi over 2. So that would be 3 pi over 2. So I'm going to get 3 pi over 2 minus arc sine of 1/3 over 2. That's definitely still between 0 and 2 pi. Remember, this was an acute angle, so we're a little bit smaller than 3 pi over 2. Now we're in quadrant 3. But I can see if I were to add another pi, it would be too big. Pretty much know. I'm supposed to have twice as many solutions as I had here, so I pretty much know I'm done. But if I added another 2 pi, I'd get to 5 pi over 2 minus this acute angle. But 5 pi over 2, that would be pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. I would have rotated past 2 pi. If I subtract an acute angle, I'm still bigger than 2 pi. Okay. So these are all of my solutions for what x could be between 0 and 2 pi.